Welcome to my channel Mathematics with Sachin Dixit. In this lecture, we continue arithmetic progression. In previous lecture, we see that let A be a first term and D be the common difference. Then the arithmetic progression, that is AP, is denoted by A plus D, A plus 2D, A plus 3D, and so on continue. And the nth term of an AP is given by Tn is equals to A plus n minus 1 into D. In this lecture, we discuss the formula for sum of the first n terms of an AP and we solve some examples on it. Sum of first n terms of an AP. Let A be the first term and D be the common difference of an arithmetic progression, that is AP, is given by A plus D, A plus 2D, A plus 3D, and so on continue. Let nth term of an AP is given by Tn is equals to A plus n minus 1 into D. Let us suppose it is equals to L. This is the last term of an AP, that is nth term of an AP. Tn is equals to A plus n minus 1 into D. We say it is equals to some L. Then Tn minus 1 can be written as, that means in this Tn we have to replace n by n minus 1. We get the term Tn minus 1. So it gives A plus n minus 1 whole bracket multiple of D. Now multiply this D in this bracket. We get Tn minus 1 is equals to A plus n minus 1 into D minus D. Means we have to multiply this D to n minus 1 and D multiplied by this one, we get minus D, and this term and this first term we have to collect in one bracket. But what is this bracket term? It is nothing but Tn. It is nth term. We say it is as L. Hence, the term Tn minus 1 can be written as L minus D. Similarly, Tn minus 2 is equals to, replace n by n minus 2 here. We get in Tn, we get A plus n minus 2 minus 1 into D. Now, we rearrange the terms in this bracket first and then multiplied by D, as it is equals to A plus n minus 1 minus 2. Just we have to change the terms, minus 1 and minus 2. Whole term multiplied by D. And now multiply this D in this bracket. We get Tn minus 2 is equals to A plus n minus 1 into D. We collect these first two terms in one bracket and multiply D to this second term. We get it is 2D. But A plus n minus 1 into D, it is nothing but nth term of an AP, which is denoted by L. Hence, this second Tn minus 2 term can be written as L minus 2D. Next, if we consider Tn minus 3, we get L minus 3D, and so on it will be continue. Then this AP can be written as, the first term is A, second is A plus D, third is A minus A plus 2D, fourth is A plus 3D, and so on continue. The last term will be L, second last term will be L minus D, next second last term will be L minus 2D, and so on. We get last three terms, we get and first three terms. And now we have to find out sum of all these terms in AP. These are the n finite number of terms in an AP. Hence, the sum of first n terms of an AP, it is denoted by Sn. And it is given by Sn is equals to A plus D plus A plus 2D plus so on up to L minus 2D plus L minus D plus L, equation number 1. Now we write down this sum in reverse order. That means here in equation 1 we take a first, that means first term is first and last term is last. Now we have to change the order, means we take last term first and first term last, and this rearrangement can be written in reverse order. This sum can be written as Sn is equals to L plus L minus D plus L minus 2D plus so on, A plus 2D plus A plus D plus A, equation number 2. Now we have to add these equation 1 and equation 2. We add equation 1 and equation 2. We get this Sn, both the terms will be the same, and addition of Sn plus Sn gives 2Sn. Then first term and this is last term, that means A plus L. Then A plus D plus L minus D. Then A plus 2D plus L minus 2D. L minus 2D plus A plus 2D. Then L minus D. Then L minus D plus A plus D. And last L plus A. This is the addition, term by term addition. Now if we observe these brackets, we observe that first bracket as it is A plus L, but in second bracket plus D and minus D will get cancelled out. In third bracket 2D minus 2D gets cancelled out. On the same line last term L plus A as it is, but second last term in second last bracket minus D and this plus D gets cancelled, L plus A will be remaining, and in this bracket also plus 2D minus 2D gets cancelled, L plus A will be remaining. In this bracket also L minus 2D plus A plus 2D plus 2D minus 2D gets cancelled out, L plus A will be remaining. Hence in all the terms remaining will be 2Sn is equals to L plus A plus L, A plus L, A plus L. In this bracket we get L plus A, that can also be written as A plus L. Here also L plus A can be written as A plus L. Here it is L plus A, we can write down it A plus L because of addition. We can rearrange the terms. But we know that these are total n terms in this equation number 1. In this equation number 1 there are n terms. In equation 2 there are n terms, and we have to take term by term addition. Therefore all these A plus L terms are nothing but n times will be there. That means this addition of A plus L term will be n times. Hence we can write twice Sn is equals to n times of A plus L. This can be written as Sn is equals to n by 2 into A plus L, equation number 3. We divide this 2 on this side. We get n by 2 into A plus L. But what is L? L is A plus n minus 1 into D. L is equals to A plus n minus 1 into D. We put this value of L in this equation number 3. We get Sn is equals to n by 2 as it is into bracket A plus, we substitute this value of L as A plus n minus 1 into D, bracket complete. Now this A plus A gives twice A, and the expression becomes Sn is equals to n by 2 into bracket twice A plus n minus 1 into D. Thus, the sum of first n terms of an AP is given by Sn is equals to n by 2 into bracket 2A plus n minus 1 into D. Also from equation 3 we have Sn is equals to n by 2 into A plus L. A is the first term, L is the last term. Hence this term can be written as Sn is equals to, this expression can also be written as Sn is equals to n by 2 into first term plus last term. This is one another formula for to finding the nth term, sum of first n terms, and here we have to derive the sum of first n terms of an AP is given by Sn is equals to n by 2 into bracket twice A plus n minus 1 into D. Now we solve some examples corresponding to this formula. We take first example. Find the sum of first 10 terms of the sequence 37, 42, 47 and so on continue. Solution. Given an AP is 37, 42, 47 and so on continue. Then here the first term is 37. If we have to take any sequence and to solve a problem of an AP, first we have to find out the first term and common difference. Here by observation A is equal to first term is equals to 37. Now we have to find out its a common difference. For that we take the term and its previous term, that is 42 minus 37 is equals to 5. Also next 47 is the term, 42 is the previous term, hence it will be 47 minus 42, it is equals to 5. The difference will be the same and it is equals to 5. Hence the common difference D is equals to 5. Hence we will write here D is equals to common difference is equals to 5. We know that the sum of first n terms of an AP is given by Sn is equals to n by 2 into bracket twice A plus n minus 1 into D. Twice A plus n minus 1 into D. Now, therefore, put A is equals to 37 and D is equals to 5 in the expression Sn is equals to n by 2 into bracket twice A plus n minus 1 into D we get. We substitute the values and here we have to find out sum of first 10 terms, hence we take n is equals to 10. We have S10 is equals to 10 divided by 2, n is equals to 10, therefore it is 10 by divided by 2 into bracket twice A plus 10 minus 1 into D. That is SS10 is equals to 5. 10 divided by 2 means 5. 5 into bracket twice A plus 9D. 10 minus 1 is 9. That is 5 into 2A plus 9D. Now we put the values of A and D here. We get S10 is equals to 5 into bracket 2 into 37 plus 9 into 5. Bracket complete. That is nothing but 5 is equals to 5 into bracket 37 multiple of 2, it is 37. So it is 74. Sorry. 37 into 2 is equals to 74. And 9 into 5, that is equals to 45. Now we add these two, 74 plus 45. Then S10 is equals to 5 into bracket 74 plus 45, it is 119. And we multiply it by 5, we get the value of S10 as 595. Thus, S10 is equals to sum of first 10 terms of an AP is equals to 595. 595. This is the first example. We solve one more example. Find the sum of first 12 terms of the sequence 7, 11, 15, 19 and so on continue. Solution. Again we consider an AP is 7, 11, 15, 19 and so on. As it is an AP, first we have tried to find out the first term and common difference, that is A and D. Here A is equals to first term is equals to first term of this sequence is 7. Now we have to find out its a common difference. For that, if we observe here, the term is 11 and previous term is 7. Therefore 11 minus 7 is equals to 4. Similarly, 15 is the term, previous term is 11, then 15 minus 11 is equals to 4. Similarly, term is 19, previous term is 15, 19 minus 15 is equals to 4. Hence, D is equals to common difference is equals to 4. Hence, we write here D is equals to common difference is equals to 4. We know that the sum of the nth term of an AP is given by Sn is equals to n by 2 into bracket twice A plus n minus 1 into D. Is the formula. Sn is equals to n by 2 into bracket twice A plus n minus 1 into D, bracket complete. Therefore, put A is equals to 7 and D is equals to 4 in the expression Sn is equals to n by 2 into bracket twice A plus n minus 1 into D. We get. Here we have to find out the sum of first 12 terms. That is, we take n is equals to 12. We have S12 is equals to n is 12, therefore it is 12 divided by 2 into bracket twice A plus n minus 1, that is 12 minus 1 into D. Now further simplification, S12 is equals to 12 divided by 2, that is equals to 6. 2A as it is, 12 minus 1, that is equals to 11, that is S12 is equals to 6 into bracket twice A plus 11D. Now I put the values of A and D here. We get S12 is equals to 6 into bracket 2 into 7, here A is 7 and D is 4. We put D is equals to 4 here, that means 2 into 7 plus 11 into 4. That is 6 into bracket 7 into 2, that is 14, 11 into 4, that is 44. Now we add these terms, we get S12 is equals to 6 as it is, 14 plus 44, that is equals to 58, and 58 multiplied by 6, that gives 342. That is the sum of first 12 terms of the given sequence. Thus, S12 is equals to sum of first 12 terms of an AP is equals to 348. 348. We solve one more example. Find sum of first 20 terms of the sequence 5, 12, 19, 26 and so on. Solution. Again start with the same. Given an AP is 5, 12, 19, 26 and so on, continue. Here first term A is 5. To find common difference, we have to consider term as 12, previous term is 5, 12 minus 5, that is equals to 7. Similarly, term is 19, previous term is 12, therefore 19 minus 12 is equals to 7. Again, term is 26, previous term is 19, 26 minus 19 is equals to 7. Hence, D is equals to common difference is equals to 7. Hence, D is equals to common difference is equals to 7. We get the first term and the common difference. Now we know the formula for to finding the sum of n terms of an AP is given by Sn is equals to n divided by 2 into bracket twice A plus n minus 1 into D, bracket complete. Therefore, put A is equals to 5 and D is equals to 7 in the expression Sn is equals to n by 2 into bracket twice A plus n minus 1 into D. We get. That means we have to put the value of A and D in this bracket. But also we have to find out here the sum of first 20 terms. That means we have to find out the value of Sn when n is equals to 20. We put n is equals to 20 in this expression first. We get S20 is equals to 20 divided by 2 into bracket twice A plus 20 minus 1 into D. That is S20 is equals to 20 divided by 2, that is equals to 10. 2a as it is, 20 minus 1 that is 19 into d. Now substitute the values of a and d here. We get S20 is equals to 10 into bracket. Here a is 5 and d is 7. Therefore it will be 2 into 5 plus 19 into 7. Now we simplify this bracket. It is equals to 10 as it is. 5 into 2 that is equals to 10. And 19 into 7 is 133. 133. Thus S20 is equals to 10 as it is. 10 plus 133 that is 143. 143. Now multiply it by 10. We get S20 is equals to 1430. 1430. That is the sum of first 20 terms. Thus S20 is equals to sum of first 20 terms of an AP is 1430. 1430. These are the three examples to find out the sum of first n terms. Now try to solve these examples for homework. These are some examples. Find the sum of first 20 terms of the sequence 2, 7, 12, 17 and so on. Similar to this is a fifth example, sixth example, 7th, 8th, 9th, 10th. Try to solve these examples to get clear idea, which is these examples are based on previously 3 examples. If we solve these examples, you get the idea. Try it. Thank you for watching this video.